Student learning target. This lesson will teach me to apply exponent rules to simplify an exponential expression and a story problem. This lesson correlates to Unit 8, Lesson 1. Some things to write down. I know that an exponential expression is simplified when, please write these 4 things down, when they have positive exponents, when there are no parentheses, the fractions are reduced, and each variable appears only once. Since this table is rather large, this video will be split into 2 pieces, as will the lessons as to Lesson 1, indicated by the rules highlighted in red, and then Lesson 2 will be a separate video. Those rules are indicated in blue. Let's begin with the exponent rule referred to as zero exponents. Any exponent to the 0 power is going to give you 1. Please keep in mind that this rule applies to what the 0 is directly touching. For instance, x to the 0 power is 1, however, negative x to the 0 power equals negative 1. This is because in this particular example, it's negative 1 times x to the 0 power. Think about your order of operations. We do things that we do exponents first and then multiplication. So x to the 0 power is 1. Negative 1 times 1 is negative 1. Notice in the medium example, parentheses are surrounding the entire problem, meaning that the 0 is essentially touching everything inside here, leading it all to be 1. Negative exponents. You might not have realized it before, but we can have exponents that are negative. Notice it says raised to the negative n power. Negative exponents create fractions. So this is going to be 1 over a to the nth power. When you drop the negative n to the bottom of the fraction, you lose the negative. Think about it this way. On one of your smartphones, when you have an app that needs updated, you get some sort of little flag that says that there's an app, or even a message that needs to be read. Once you update the app or read the message, that flag goes away. The negative exponent is essentially a flag saying, hey, there's something that needs to be messed with here, meaning you need to create a fraction. Looking at the next example, x raised to the negative 3 power. The negative 3 is telling you that a fraction is coming. You get rid of the negative by dropping your exponent to the bottom. Because this fraction has nothing on top of it when you drop it, we fill the top with a 1. Look at the harder example, the medium example I should say. I see a negative exponent, so I'm going to create a fraction bar. The negative 2 is only touching the b, so that's the only thing that needs to come down to the bottom. The a to the 6 has a positive exponent, so it's going to stay put. Again, my analogy about apps on your phone. If you have multiple apps, which we all do, you're only going to update the app that has the particular notification, not the one that has no notification. So in this example, a to the positive 6 power, there's nothing you can do with it. It stays put. The negative on the b to the negative 2nd is telling you, hey, something needs to happen here. That is going to be put at the bottom of the fraction. The other negative exponent rule. Look at these examples. Where is the negative exponent in comparison to where it was in the first one? The negative's in the bottom. Negative exponents still are going to deal with fractions. However, here, because the negative is in the bottom, it ends up coming up to the top. If you think about fractions, we can always put things under 1, but don't necessarily need to put the under 1, so we'd refer to this one as a to the n power. Here as well, I can go ahead and make a fraction bar. The negative is in the bottom, so that's what's going to change. I'm going to bring up the 2 to the 2nd power. There's no longer a negative because it's been moved. I can put a 1 under anything, but I don't really need it. 2 to the 2nd power is 4. Again, I see a negative exponent, so I'm going to make a fraction bar just to be safe. This negative 2 really has an exponent of 1. Even though the negative 2 is negative, the negative's not in the exponent, so it's going to stay put. The x to the negative 4 power is where the negative exponent is. To get rid of the negative exponent, I bring it up to the top and I lose the negative. So this particular answer is negative 2x to the 4th power. A quick recap here of these then. If the negative exponent is in the top of a fraction, it moves to the bottom, loses its negative. If the negative exponent is in the bottom of the fraction, it moves to the top and loses its negative. So that negative is a flag that it needs to change position, either from the top down or down up. Multiplying powers with the same base. This is a to the m power times a to the n power. What you do when you have powers being multiplied by the same base is you end up adding the exponents. So this is going to look like a to the m plus n. In your notes, I believe that's a positive 5. So think about what exponents mean for a moment. X to the 5th means x times x times x times x times x times x to the 3rd, well there's 3 x's there, times x to the 2nd, well there's 2 x's there. Exponents are repeated multiplication, x times x times x times x times x times some more x's times some more x's. So how many x's are really here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X to the 10th power because 5 plus 3 is 8 and 8 plus 2 is 10. Last problem here. Couple of things, and students can very often get confused with this one. The 2 and the 3 are just plain old numbers. Think about multiplication because that's all we really have here. I can change the order of multiplication. This problem can be rewritten as 2 times 3 times x to the 5th times x to the negative 2nd. Well, 2 times 3 is 6. Those are normal numbers. They're not exponents. They're not getting added because they're not powers. They're the normal numbers. So if I have x to the 5th, that means I have 5 x's. X to the negative 2nd, negative 2 x's. So if I add those two things together, I have x to the 3rd. Thank you very much. Let me know if you have any questions.